This is the answer for homework 10, question 2. So the question asks us to go over different types of stochastic processes. Only these, what was different from question 1 is that these processes we actually use to describe specific examples of stochastic processes. So these are almost like properties. So the first one we're going to go over is the wide-sense stationary process. So basically a wide-sense stationary process is a process with the mean being a constant and with the autocorrelation being only dependent on tau. And so basically both mean and autocorrelation are time invariant, so they aren't dependent on any specific changes in time. And an example of a wide-sense stationary process, there's lots, but the example I wrote down is the random telegraph signal. So wide-sense stationary processes are also strict-sense stationary, but not the other way around. So the next process is the independent increment process. So basically, time intervals do not overlap. So i.e. x of t1 minus x of t2 and x of t3 minus x of t4 are independent when they're non-overlapping. So examples of this type of process are, I went over a few of them I went over the Poisson process in my previous video. But yeah, so basically the Poisson process is an example of an independent increment process, and the Bernoulli process is an example of this as well. The next type of process is the Markov process. So it's basically a process where past events have no impact on or influence on the future. And so another word for this type of process is memorylessness, basically. So it's kind of the basis for a lot of things that require a steady state where it can't be influenced by something in the past. So things like a cruise control system, in order for it to maintain the same velocity, it can't be influenced by velocity a previous velocity. So for example, when you're driving up a hill, you have to even though the car is decelerating when you're not putting gas into it, the way the system works is it would always maintain the same speed no matter what was causing the car to decelerate a second ago. So other examples of the Markovian processes or Markov chains are popcorn popping in a microwave, where each kernel that pops doesn't influence the next kernel being popped, and lots of forms of gambling. So for example, slot machines, every spin of the reels is independent of any previous spins, ideally. So the next type of process is the normal or the Gaussian process. So the definition for this is that x of t is called normal, so x of t would be the process, and it's called normal if the random variables from xt1 all the way to xtn are jointly normal for any n, so any mean, and for any time points t1 to tn. So this is basically a process that's time continuous, and it's used a lot in any applications where we need to extract, say, a mean or a variance. So this is kind of the basis for the normal distribution, which we see a lot in scientific reporting and the scientific method. The next type of process is the strict-sense stationary process. So this type of process is not affected by a shift on the time axis or by a shift of the origin. So therefore, x of t and x of t plus c have the same statistics. So you're going to have the same mean and the same autocorrelation, autocovariance for x of t and x of t plus any constant, so any shift. And then the last property or process is white noise. So the definition for this is that v of t, which would be the white noise, is white noise if its values v of ti and v of tj are uncorrelated for every ti, where ti and tj are not equal.